It's great to be here virtually. So today, when Odette invited me to talk about this, to talk about some of my research, I at first had a kind of a hard time because I've been spending so much of my life thinking about music and why we have music, but also recently I've been moving more and more towards using the work we learn from music cognition to help folks who need it the most, and that for the past couple of years, my work has involved a lot of clinical research that includes thinking about why dance interventions might be helpful for Parkinson's disease, but also why music might be helpful for those with Alzheimer's disease. Is there somebody who's not muted here? Is there? I think there's some background noise. If I could just oh, thank you. I think that's better now. Yes. Yeah, but I thought today I would do a little bit of both and present some of the more basic research on the genesis or the beginnings of music preferences and music predictions and musical knowledge, but also hopefully touch on a little bit of the work that makes it applicable or clinically relevant to those with different diseases and disorders. And I think the key insight is really about how music moves people, right? So, and when we talk about music that moves, right, I can play a little, very well-known sound clip here. So you might recognize this piece. You have heard something quite like it in the past. Right, so of course that was a clip of Beethoven's Ninth from the Ode to Joy final movement. And maybe when you think about this piece of music, it brings to you certain feelings of joy, right? Or maybe you're in an ensemble that has performed this before, maybe you were part of the choir, maybe like me, you were a small violinist in a big gigantic ensemble, and playing that kind of brings good memories. It has a certain autobiographical salience. But maybe this is not your thing at all, right? Maybe you're more of this kind of musician. So this is actually a live performance of a band called Pavlov's Dogs, which is a group of neuroscientists that together are also interested in music playing. And so this is Tim Bussey. This is Earl Miller, who was editor-in-chief of the Journal of Neuroscience for a while, right? So these are card-carrying neuroscientists who actually get together and play these rock songs, and so quite a different kind of musical experience from the first kind. But this is no less legitimate and no less interesting and autobiographically salient kind of musical experience, right? So how do we think about music in a way that's maybe more genre-free and more inclusive of all the different kinds of preferences and musical selections that people might have? But when we look at people's experiences to all these kinds of music, there's a certain set of aesthetic responses that are often reported, right? So a lot of folks, when they're listening to music, they say that they get chills when they hear like pieces of music that they most enjoy. In specific moments, they are often able to pinpoint certain moments of pieces of music. So for example, I really love Rachmaninoff's Second Piano Concerto, right? There's a certain chord progression that when it happens, it just sets up this really kind of moving experience for me, and I feel like my hair is standing on end when that's happening, right? So you hear these kinds of reports, and you also hear reports like, oh, this piece of music makes me want to cry, or brings tears to my eyes, or it makes my heart skip a beat. So there are these different very visceral responses that seem to be shared across different musical genres. And so a couple of years ago, we did a survey study using this technique called multidimensional scaling, where we had a few hundred listeners just say what kinds of strong emotional responses they tend to get when they are listening to music. And then we applied this multidimensional scaling statistical analysis procedure on the data. And so what we're seeing here is a result of that, where it's a two-dimensional space where responses that are in the same part of the space are more frequently co-occurring or co-reported among our respondents. And so you can see that the people who say that they get heart skipping a beat when they're listening to music also tend to say that they feel like their heart is racing, right? Or people who say that they're in awe or also tend to feel like they're getting touched. They're feeling touched by music. And chills shows up in the middle. So that says that a lot of different responders all say that they're getting chills when they're listening to music. And then the other really interesting thing is that heart racing, heart skip a beat, hair standing on end, pit in the stomach, lump in the throat, anything that actually mentions a part of the body shows up on one side of this plot, whereas anything that's more abstract or maybe even more transcendental, like the feeling like you're somewhere else, or feeling like music has transformed you to lose your sense of time, or feeling like you're in awe when you're listening to music, or feeling that you're absorbed, right? Those tend to show up on a different side of the plot. So this means that there are some people who tend to get visceral responses to music, and others that tend to get more abstract or cognitive or transcendental responses to music. And both of these above groups tend to share the property or share the experience of chills when they're listening to music. So that's the thing that we wanted to get at. And so just for fun, we could also do the same kind of multidimensional scaling to people's preference for musical genre. And so, as I said, right there are a lot of folks who say that they like classical music. They say that they also tend to like jazz music or pop music or soundtrack music. And then there's a whole other group of folks that like heavy metal music, but those folks are also more likely to like funk and punk and reggae and new age music. And then the people who say that they like religious music are also likely to say that they like country or gospel or opera music. So it's really a smorgasbord of different tastes and different preferences, and maybe I started out as a classical musician, very much liking the classical pieces, and then I really got into jazz, and now I'm really into blues and bluegrass music, right? And so, maybe by the time I retire, I'll be really into, rap music. But this is just really a way to show that the different experiences we have are not necessarily dependent on genre. And so how do we actually capture these strong aesthetic experiences to music? So what we can do is we can record from skin conductance, right? So how sweaty your skin is. When you're listening to music that gives you the chills, you're literally experiencing a chill, and you can record that using skin conductance measures on the surface of the skin. You can also record heart rate. And so when people are listening to music that they enjoy, their heart tends to beat a little bit faster. And so what Matt Sachs did a few years ago now was he recruited listeners who tend to get strong responses, emotional responses to music, and people who don't report strong emotional responses to music. So we'll call the first group the chill group, and the second group the no chill group. And first of all, he recorded that the skin conductance and heart rate from these two groups of listeners while they were listening to music that they brought in as their favorite pieces of music, and also listening to control pieces of music that somebody else brought in as their favorite pieces of music. And what we saw was that whenever the chill group was listening to pieces of music that they enjoyed, they tended to get strong increases in skin conductance, right? So they were more sweaty, and then their hearts were also beating faster, right? So there was a shorter interval in between different beats of heart rate. So that was just showing that the psychophysiological responses scale with the independent ratings or self-report measures of musical experience. Then we also wanted to ask whether there's something structurally different. There's some structural differences between the brains of people who tend to get strong emotional experiences when they listen to music versus people who don't, right? And this comes from some work in functional connectivity from the Satori lab and other labs that have shown that when you're listening to music that you enjoy, it's not just that your auditory areas are active, your auditory areas are actually more functionally connected with areas that are important, that are part of your reward system. So the areas of your brain that are active when you are eating really good food, or when you're gambling, or when you're thinking about somebody that you really love, those areas that are active are part of the dopaminergic reward system. And what other labs have shown is that the auditory areas tend to be more functionally connected or more correlated in activity with these reward system areas during music, when you're listening to music that you enjoy. And so what we saw was that we looked for specific structural connectivity, right, actual brain structure differences between people who get chills and people who don't get chills. When you looked at the connectivity between the auditory, the areas that are important for auditory perception and the areas that are important for emotion and reward, we saw that, in red, I'm showing you the connectivity pathways that we traced between these several areas in the chill group, and in blue, I'm showing the no chill group. And you can see that there's more red than blue, which suggests that there's larger areas of structural connectivity that are involved in the connections between the auditory system and the reward system. So that's really exciting, right? So, and in the way, if you think about that, that's really quite surprising. What we're seeing is that there are actual differences in brain structure that track with how emotional or how strongly you tend to feel emotions when you're listening to music. And so, and that structural connectivity seems to come down to the crosstalk between the auditory system and the reward system. So after this paper got published, we had one gentleman, we'll call him BW, who got in touch with me. So he, it was quite by chance that he was married to somebody who was an alumna of Wesleyan University, where my lab was at the time. And so having heard about this work, Wesleyan wrote a newsletter article about this. And so he read the newsletter and said, oh, I actually have this condition known as musical anhedonia. So this is somebody who, is quite an avid reader of the news and heard about the work on musical anhedonia that was reported from other sources, I think from NPR, which is, so from other sources. And then he came to my lab, saying that he had musical anhedonia. And at first, we just said, well, maybe let's just verify this. And so you can verify this using a neuropsychological measure called the Barcelona Music Reward Questionnaire, which is simply a questionnaire that has a set of questions about how much you tend to seek music, right? So if you say that, well, I often look for new music to listen to, right? That's part of the music seeking scale. It also has questions about emotion evocation, right? So how strongly music tends to elicit emotions within you, right? So when I listen to music, I feel sad, right? So that's a music evocation item. Or you can also say that you use music to regulate your own mood, or that you tend to dance to or move along to music, like that's a sensory motor subscale. Or you could say that you tend to seek out music that that your friends enjoy, right? So that's music as a social reward. And so we got BW to complete this questionnaire, and we also wanted to include a control questionnaire for more general forms of hedonic responses. So this is known as the physical anhedonia scale. So it asks things like, how strongly do you enjoy good food, right? Or do you like the sounds of rustling leaves in the forest, right? So these are hedonic responses that are not necessarily musical, but they are just a general form of hedonic responses. And people who have, for example, depression, right, or early Alzheimer's disease, right, they tend to have more generally blunted hedonic responses to not just music, but to a variety of different stimuli. And so we're using the physical anhedonia scale to rule out the possibility that BW might just be generally anhedonic. And so what we're seeing here is that BW was really, really much lower than controls and much lower than the published norms in all 5 dimensions of the Barcelona Music Reward Questionnaire. And he was also very much abnormal or very anhedonic in his responses to sounds, even non-musical sounds, just the sounds of in the environment that other people might find pleasing. He didn't find them to be pleasing at all. But then he was not anhedonic in response to non-sound items. So he was just as likely to like great food as you and me. He was just as likely to enjoy a good back rub or a long walk on the beach as you and me, right? So in that sense, he was not generally depressed. He just didn't find sounds to be appealing. And so we also had BW listen to songs that a lot of folks in our studies usually enjoy. And so here is a playlist, a short list of music that our participants in the previous study had listed as being more quite pleasurable to them. And so we played them this kind of hit list, and we asked them to ask BW and some control listeners to rate how strongly they preferred these pieces of music. And while most other listeners rated some pieces of music as being chill-inducing and also as showed skin conductance that scaled with the behavioral ratings, BW, on the other hand, did not show that pattern at all. So not only was he not likely to experience the pieces of music as enjoyable, he also did not show physiological measures of music enjoyment. And what we then saw was that the structural connectivity between auditory areas and the reward areas, specifically in nucleus accumbens, which is a subset of the reward system, was much different and altered in BW's brain compared to a larger group of controls. So all this together is to say that you can think about certain neural networks in the brain that might be important for listening, so specifically forming auditory predictions, and also its connections with the reward system. And so Amy Belfi and I kind of mapped out these set of brain regions that might be important for music and reward. And maybe it's the disruption of this connection between auditory system and reward system that gives rise to musical anhedonia, specific musical anhedonia. And so this is just diagram, anatomical diagram of where the regions are that might be important. So you can actually translate this into brain space. And so finding the auditory network and finding the reward evaluation network, and then testing this model that we had proposed here by looking at the functional connectivity or the correlation between these different sets of areas. And this is exactly what my student Diana Wang did in her thesis. What she did was take a large set of resting state functional MRI data that's from openly available from a database called the Alzheimer's Disease Neuroimaging Initiative. And what she can do then is pull out the connectivity between the auditory system and the reward system in resting state brain data. And she can do that for both healthy older adults and also folks with Alzheimer's disease and folks with mild cognitive impairment. And so you can see that as the disease severity increases, right, from healthy older adults through folks with mild cognitive impairment, through to folks with Alzheimer's disease, you end up with less and less of this functional connectivity between the auditory system and the reward system, and also within the auditory system and within the reward system, there was a general reduction in functional connectivity. However, there was some overlap in between these two areas, between these two networks, that was still persistent even in folks with more severe Alzheimer's disease. So because of that, I think that this functional connectivity between the auditory network and the reward network is a target for music-based interventions, right? And so you might have seen some kind of striking videos of older adults who have quite severe Alzheimer's disease. They might not be able to recognize their family members. They might not know what year it is. And yet when they hear a certain piece of music, especially from their youth, it's like something just lit up inside, right? And suddenly they're really excited and they're very talkative and they suddenly recognize people. And so what is it that's happening in the brain to enable this, and how can we turn this into an intervention so that we can systematically, maximize its, the benefits of music listening on, on the brain and on motivated behavior. And so we are working in the lab on a music listening functional MRI task, right? So where we can have people listen to pieces of music that they choose, right? Because, well, the clinical intuition there is that when people with Alzheimer's disease show that really striking reaction to music, it's usually to music that they choose to listen to, or that they knew even before the onset of Alzheimer's disease. So self-selected music was very important. We also had music that we gave them to listen to, right? That is popular from different time periods and from various genres. And we had these listeners listen to all these different kinds of music and then rate how much they liked the pieces and how familiar they found the pieces to be. And we did this with young adults who are university age students, and then with older adults age 50 and above. And so the main result there is that everybody shows more activity when listening to music that they chose to listen to compared to music that other people chose to listen to. But older adults show actually more brain activity, especially in the auditory system and in the reward system. However, we then went on to do, working with a music therapist named Suzanne Hanser, who founded the Berklee College of Music music therapy department there, and then working with a neurologist, Dr. Maya Geddes, we designed an 8-week music-based intervention on these older adults, where a music therapist would work with these older adults to come up with pieces of music that they would choose to listen to, and do mindful listening for an hour a day for 8 weeks, and write about their experiences in a journal. And then pre and post this 8-week intervention, we scanned their brains while they were listening to their own selected music and other music. And so what we saw was that after intervention, these older adults actually revived some of their activity in the reward areas of the brain, specifically in this region of the medial prefrontal cortex, which you don't see to be active when listening to highly rated music in the older adults. We actually see an increase in activity in this specific region that's part of the reward system, so such that the older adults' activity end up being more like the young adults. So that was really exciting. So we also wanted to know whether this increase or this change in activation of the reward system was related to the auditory activity at all. And so what we then did, this is work by Alex Belden, who's a grad student in my lab, is we took the specific activity of the auditory system and we traced its connections to the medial prefrontal cortex, and we saw that was an increase post-intervention, and we also saw that particular correlation was increased for self-selected music compared to other selected music. So there's something about this auditory to reward connectivity that seems to change throughout life, but it seems to be specifically related to music listening, and it seems to be increased and engaged by longer-term interventions that use receptive music-based listening as an active ingredient. So, but then the question so far, right, is that what we've seen, hopefully, from the data I've shown you so far, is that listening to music is intrinsically rewarding. When you listen to music that you enjoy, you activate the reward system. And in a way, that's not so surprising, right? Because if you like something, then of course it's going to be visible in the brain. But really, what's the question that's more exciting to me is, where do these reward values come from, right? How do you take a piece of music that you've never heard before, and how does it somehow become valuable to you, or how does it somehow become rewarding to listen to music? And this is something that would be useful for, let's say, for composers, right? How do you think of music in a way that is maximally engaging to the reward system of the brain? And so one of the working hypotheses that's like out in the field right now is that there are these musical features, right? So music certainly has melodic features, harmonic features, rhythmic features, that when you get exposed to them throughout life, when you get exposed to the acoustics and the statistics of music throughout life, you then acquire these predictions. And by predictions, I mean certain knowledge that you might have even before you hear specific instances of sounds themselves, right? So you form certain expectations or certain anticipations, or you develop knowledge that you might have in your brain that's in advance of hearing specific instances of sound. And so that prediction then becomes rewarding, right? So it's this mapping of musical features through our learning of predictions towards reward that gives rise to music becoming enjoyable to listen to. And so this is an idea that's been out there since the 50s by the influential Leonard Meyer, who wrote in the book on emotion and meaning in music, that slight violations in expectations cause emotion and meaning in music. This is also something that picked up by Berline in the 70s, by kind of the classic work on empirical aesthetics, positing this inverse U-curve relationship between arousal and preference. And then more recently, David Huron and others have also talked about the importance of predictions in generating musical preferences. But nobody has actually been able to map the beginning of how predictions get turned into reward. And because there are so many sounds and acoustics with their acoustical properties and statistical properties that we've all been exposed to in our lives and in our cultures since day one, right? Maybe even before you were born, you've already heard sounds from the mother's womb that have already informed you of certain predictions that you might have and that you should have even on day one of life. And so it's kind of impossible to capture all the sounds that you would have heard from the moment you were born, or even before you were born. And so one set of predictions that we have are for the musical scales of our culture, right? So, for example, in the Western world, we're used to the equal tempered Western chromatic scale, right? And so that's based around the 440 hertz, and then an octave below that would be 220 hertz. So this is what Western chromatic scale sounds like. All right, so now can we come up with a different tuning system that then generates or engenders a large new set of predictions? So the way to do that, there's a new scale called the Bolin-Pierce scale. So Heinz Bolin and John Pierce independently started to ask, why does music have to be tuned around the octave? Why can't it be tuned around the tritive? And so they came up with this 3-to-1 ratio, and within that ratio, they thought of 13 logarithmically even steps along the scale. So it sounds like this. All right, so why 13 steps? Well, it turns out that if you pick certain notes along that scale and you play them together, they can approximate a low integer ratio. So in this case, a 3 to 5 to 7 integer frequency ratio, which when you play them together, they sound smooth and consonant. And so that becomes the new chord in your musical system. And that then can sound relatively acoustically plausible, even though statistically you've not been exposed to those chords before. So leveraging the fact that this Böhlen-Pierce scale is quite unfamiliar to everybody, unless if you're an avant-garde musician who has spent, a PhD dissertation career studying the Böhlen-Pierce scale, which is quite rare. For most of our participants, we can be pretty sure that they've not heard of the Böhlen-Pierce scale before. And so then we can now compose some chord progressions using the scale, and then we can compose some melodies using these chord progressions. So this is exactly what Yuan Zhang, who's a student in my lab, did. So he played some melody, he composed some melodies. Here's one of them. Right, so that's one melody, one of many melodies that he composed. And so what we did was we had different sets of different melodies, a large set of different melodies that we had people listen to over the course of an exposure period. So essentially, we're coming up with a new musical world that you can step into and hear music in that world for the first time. And unbeknownst to the participants, different melodies were exposed different times. So some melodies they didn't hear at all. Some melodies they heard 2 times. Some melodies they heard 4 times or 6 times or 8 times and 10 and 14 and 16 times. So just within this overall exposure phase. And during the exposure phase, we had a cover task where people had to listen to these melodies. And whenever there was a vibrato, so a rapid amplitude modulation in one of the notes, they had to press the B key on their keyboard. So this is what that vibrato sounds like. Great, so you could hear that one of the notes had a vibrato in it, and that was the target note you had to respond to. And then at test, we also, so after people heard these melodies for about 20 to 30 minutes, then they also had to rate how much they liked each melody. And when we asked them how much they liked each melody, we included all the melodies that they'd heard either 2, 4, 6, and 8 times and so on. We also included some melodies that started just like the melodies that I heard before, but ended with a slightly different ending. So this is an error in prediction that we introduced at test. So hopefully you heard that the ending of that melody was different from the melody that you heard in the 2 previous times before that. And so in all cases, people had to listen to these melodies and rate how much they liked them before and after exposure. So after exposure, here I'm going to show you how much they rated each piece as being well liked. So the preference ratings, liking ratings on the y-axis. And then on x-axis, I'm showing you the number of presentations separately for the original melodies and the manipulated melodies that had a different ending from the ones that were heard during exposure. And the results were very clear in showing that the preferences scaled with the number of presentations, but also were reduced by the effective manipulation. So the prediction error that was introduced within each melody resulted in a reduction of preference. So people consistently prefer melodies that were presented more. So the stronger the prediction, the stronger the preference. And then an error in prediction, which was violating the structure that they begin to learn throughout the course of the exposure, tended to disrupt the preference ratings. And then interestingly, we also did this for for not just folks in the U.S. Who are online listeners, but also on folks with on folks in China. And it turns out that people in China also did exactly the same thing. They preferred the more frequently presented melodies, and they did not prefer the manipulations. So this process of generation of prediction reward from predictions seems to be relatively similar across cultures. But people for whom it was not the same was people in people who had musical anhedonia. So we also did the Barcelona Music Reward Questionnaire in each listener, and then we broke the data down by whether by how strongly each listener showed a hedonic response to music. And it turns out that people who were in the musical anhedonic group tended to not show this relationship between preference and liking. So even though their familiarity ratings scaled with the number of presentations, their preferences did not scale with repetitions. So it seems like there's something that's different in the mapping between predictions and reward in this special population. So I think I'll stop there. I mean, there's a lot more I could go into, but I think oops, I'm sorry, I can't find my mouse. But the thing that I wanted to talk about the most was really about how predictions generate reward, and how that process, that mapping of predictions to reward, is something that you could test empirically using new music, but it's something that we could also make use of for folks that have a special needs for music-based intervention. So designing thoughtful music-based intervention programs for people who need it the most is something that is maybe a practical consequence that this mapping between auditory predictions and reward can bring. And also, I think that it's of maybe of like most importance and most interest to people who make new music is why music becomes rewarding, and maybe thinking about reward prediction error in this way might be helpful for making exciting new music as well. So I think I'll stop there. I don't know why I still can't find my mouse. It seems to, oh, there it is. Okay. Yeah, but I mean, all this work is not really possible with just me. So it was the work of many different students in my lab. So I just wanted to highlight a little bit the different students who were part of this project. So mainly Parker Tichko, who's a postdoc in the lab, Alex Belden, who's a grad student in the lab, Alex and Milena Quincy, who's the lab manager in the lab. They have a couple of preprints that are in review right now. Hopefully will come out soon about the work on music-based interventions. And then Nick Kathios is the PhD student in the lab, who's the first author on the work on the Bolin-Pierce scale. And then Diana Wang is the one whose thesis we established this network of auditory and reward systems that we're using in the lab right now. And this work was supported generously by the National Institute of Health and National Science Foundation, and also the Grammy Foundation and Kim and Glenn Campbell Foundation. And I'll also say that we have the project was not possible without also consulting people from different fields and different parts of the world. And so we have a book that's coming out towards the early next year. So it's in proof stage right now. And it's really a set of interdisciplinary essays on music psychology from humanistic and artistic and scientific ways of knowing. So it brings together all these different scholars, and it's in press at MIT Press, and the title is Science Music Borderland. So I just wanted to mention that. Yeah, and then I'm happy to take any questions. Thank you.
Thank you. I have to say that I have the first question from the resident neuroscience expert sitting right next to me.
Oh, hi. Thank you for a very interesting talk. So I'll make a brief statement followed by 3 very short questions. Okay, so you told us about individual differences in the link between 2 domains, cognition and emotion. Experience varies with self-reports. So self-reports match the physiological and neural responses that you see, or the structural connectivity. To me, it sounds a lot like synesthesia. And in fact, the general neural explanation of synesthesia is the cross-activation theory, which says there's probably additional connections, or perhaps functional connectivity if it's short-term. And that raises a number of short questions, which may not have short answers. First, what do you think about that link? Secondly, do you think we're talking here about a genetic predisposition? Are these, would you see the cross, the connectivity, the structural connectivity in newborns? Maybe if it runs in the family, you will see those connections, and then somehow the function may be acquired later. It will then have some implications for your attempts to cultivate it or kind of encourage that. And the question is, can you, in synesthesia, it's quite difficult to make someone a synesthete if they don't have the predisposition, but it's certainly true you can modulate that. So I think I'll stop here. I'll just ask if I missed that, when you talked about Alzheimer's disease, is there anything particular about Alzheimer's, or are you talking about dementia in general and kind of just a shorthand?
So many questions. So yeah. How much time do you have?
Whatever Oded allows.
So many questions. So yeah, let's start with the synesthesia stuff. Absolutely. I mean, I think a lot of the same mechanisms that we're talking about, like prediction, statistical learning, exposure, and then mapping those predictions to certain other, the concurrent sensation in synesthesia. I think that is the same mechanism. I think the reward mechanism might be a little bit different, right? As far as my reading of the literature, it's not. So let's say if you have a graphene color synesthete, they might say, well, I like to put these certain letters together because it gives rise to this very pleasant set of colors together. But that's not, it's not so much a one-to-one mapping between specific stimuli and reward that we think that music is, there's something about music being unfolding in time that seems to be particularly helpful for our conceptualizing it as prediction and reward mapping. Whereas for synesthesia, I think of, certainly associations and statistically learned or stimulus properties and them being mapped together. And so that's maybe more where that's at. I am very interested in seeing where these predictions come from, even for folks with synesthesia. So spent a little bit of time doing some work on synesthesia, and there was one girl who told me that she went to study abroad in Russia, and during that semester acquired letter color mappings for the Cyrillic alphabet, right? So for the first time, and so that was really interesting to me. So she must have had some kind of predisposition or kind of brain wiring in place to and then to kind of receive these new categories that were coming in for de novo. So that was super interesting. Another time I played, a friend of mine has synesthesia. It was sound to color synesthesia. And I guess you have multiple synesthesias. I played her some pieces of music from the Bohlen-Pierce scale, and she said, I see purple clouds and I taste marshmallows. So that's the kind of thing that is really striking. But you clearly hadn't heard that piece before. So it's like this. So I think there is this predisposition. But in terms of where this prediction and reward mapping comes from, it might be a little bit more late emerging. So we haven't done enough developmental work to be able to answer this for sure yet. But certainly the ability to learn from predictions probably starts very early, but then the ability to map those onto reward, as in the reward system, might be something that's relatively late. So for example, very young children don't say that they don't report getting chills to music. And they also don't report like seeking out new music in the same way. So we have Nick Kathios, who's the grad student that did the generation work. He's actually shown that when you listen to music that's from your childhood, it activates somewhat different sets of brain regions and includes less of the reward activation compared to when you're listening to music from your adolescence. So there seems to be something in adolescence where there's additional connectivity between auditory and reward systems that seems to emerge. And I think that might be why we have this famous effect known as the reminiscence bump, where when you look at people from their 60s, you ask them to bring in music that they enjoyed the most. It's more often than not from their adolescence and young adulthood, right? So there's a certain time, kind of golden period when that happens. Yeah, and then the relevance to the Alzheimer's disease. So I didn't go into some of the more novel forms of Alzheimer's disease interventions that we're working on, but the lab focuses on music-based interventions, more traditional receptive music-based interventions like the one I presented, but we also are interested in specific ways that target the specific mechanisms that are disrupted in Alzheimer's disease. So especially we know that people with Alzheimer's disease, they have plaques and tangles and beta amyloid deposits in the brain, and that's linked to rhythmic differences in how the theta and gamma bands in the are coupled together, and that then subserves working memory. And so what we're trying to do is come up with a novel intervention that uses specially tailored musical experiences, music and visual experiences, to insert those kinds of rhythmic stimulation to the brain. So essentially rethinking music as a kind of rhythmic brain stimulation. And so that, I would say, is more specifically targeted at Alzheimer's disease, but the more general music listening based interventions, for now, we've done this on healthy older adults, and we already see these differences. So it might be a bit more general. Yeah.
Thanks. We have a question from Hussein.
Thank you very much, Oded. Thank you very much, Psyche. That was very interesting. I suppose I've got two things really. One is an observation based on my own children, which is that they're into this thing, JoJo's Bizarre Adventures, which essentially, every stand or the power that each character has, it's essentially associated with kind of a classic rock type sort of band or song. So the interesting thing about the discovery of music becomes when they're immersed in the game or watching the shows, they are then also being inculcated in music from the late 60s to about the mid 80s, early 90s, right? Like the author's taste is, so you'll have a power that's called like the sheer heart attack or the crazy diamond, or there'll be the Iron Man or something, right? So that's going to be an interesting one to kind of observe, because it feels like a very extended 1960s, 1970s that will go on forever, potentially, if it remains popular. But anyway, that's an observation about people sort of, because what started to happen is and the 9-year-old was saying, do you want to look at my playlist? And it was full of like Rolling Stones and Jimi Hendrix and stuff. And I don't inflect any of my taste on my children. I let them find their own way. So it's quite interesting that they do that. So that might be something worth looking at. The other thing I was considering was the idea of emotion, but the idea of discovery of new music that is emotional, that is triggered by visual events. So therefore the occurrence with, say, a film or a particular scene, the number of times, say when the London Olympics was on and Elbow was closing the London Olympics, their song Overnight streamed they had 800,000 or so purchases of the song because of the Olympics. Basically people who'd never heard it before suddenly equated it with an event, and therefore that then took on a new level of meaning because that was their exposure to it. And so the question, so there's also stuff within the general kind of visual consumption with music as underpinning the kind of narrative, where you would discover new music, and therefore your consumption of that music will potentially also then be through your observation of that kind of scene. I was wondering whether that was something you might sort of plan to do in terms of, because of your goals in terms of compositional stuff, in terms of how to generate more excitement or emotion or trigger more emotional responses. That, because obviously you're dealing with music that is not conceived with the visual in mind. It's those kind of two things kind of coming together that that sort of creates these kinds of triggers and kind of new associations, I suppose. So I was wondering whether it was something you kind of considered.
Yeah. I mean, I'm definitely interested in the visual experiences that can be concurrently generated because of certain musical experiences, or because of just the auditory stimulus. So didn't get time to talk about this, but working with Lisa Margulis, who's at Princeton, they've done a lot of work now on the kinds of spontaneous stories people imagine when they're listening to music. So, why is it that, when you take this piece of music with like a twang, right? And all these American folks hear cowboys, and then the Chinese folks, who are in this remote village in China that don't have much experience with Western media, they don't hear cowboys, but they hear like mountains, and then in some cases they hear communism, which is very interesting in itself. So that's something we're trying to replicate and extend with with new stimuli. Right? So when you hear Bull and Pierce music for the first time, do you hear do you bring in your rich experiences with media exposure from music from other parts of your life, right? So one striking example was that the same melody that I played you before, the Bull and Pierce melody that Ewan composed in my lab. A lot of American listeners heard Pink Panther, right? And obviously it was not the Pink Panther melody, but there were certain melodic structures perhaps that were similar with the original Pink Panther theme. So I think we do bring a lot of these extra musical associations to bear when we're hearing music for the first time. Yeah.
I mean, one of the things that
maybe.
Oh, sorry.
Maybe we let. I don't want it to be a two-way.
I was just going to say that William Russo, the composer who did a lot of stuff for like things like Beverly Hillbillies and stuff like that, the way that composers worked in Hollywood, especially with very excessive tight deadlines, were essentially to create rhythmic scores to which then they would adapt the notes and the arrangements so that they were able to reuse these rhythmic scores in a similar way that Milton Babbitt also did with his total serialism approach in terms of rhythmic rotational arrays, being able to use that. So that might be a way to kind of do something to be able to shift between lots of different scales, but keeping the same kind of rhythmic underpinning, and to see whether that sort of generates any other kind of interesting data. So that was my suggestion anyway. Thank you.
Right, and Federico, you definitely deserve a question.
Hi, thank you very much for your talk. I'm not an expert at all, but I just wanted to ask you a question in relationship to just asking whether there is a point of saturation where something predictable becomes boring. And because it seems to me that might also be kind of like, when something statistically becomes a little bit too predictable, then your reward system might not be that excited anymore. So
great question. Yeah. So we actually have been trying to find when that inflection point is, or how many repetitions, how many presentations does it take for you to just get tired of it? And we have not yet found that in the Bull and Pierce melodies, and probably because they are quite different to start with, and they're quite complex. And but when we also come across other kind of constraints on the experimental design side, because if we're trying to present something 40 times, right, then maybe there's just a lack of variability that's driving the reduction in the reward system. So we want to make sure that overall variability and overall information content in the experiment experience is still controlled for, so that we're still thoughtful about that as we try to probe when that inflection point happens. But I can tell you that with more kind of careful modeling of the behavioral data, we do see that the initial generation of the relationship between predictions and reward, it follows a more, it's not a strictly linear curve, it follows a more logarithmic shaped curve to start with. So the first few times you hear it, it increases your preference, but then by the 10th time or so, it becomes a little bit more slower to increase. But then if you are one of those people with musical anhedonia, then it just falls off after about 10 repetitions. Yeah, so I think the relationship is very interesting and very complex. So I can imagine many more studies in the future where we try to systematically manipulate the number of presentations while also keeping the overall variation and the number of repetitions themselves to be consistent. Because we also know that stimulus repetition itself can also change preference and also change how musical, the perception of musicality in pieces of music. So the famous speech to song illusion, where you say, you take a segment of speech, right? That's like a paragraph of speech, and then you take a certain subset of that speech and you loop it. And as you loop it, you start to hear that not as speech, but as music, right? So there's this shift between speech sounds being perceived as speech and speech sounds being perceived as music, and repetition seems to drive that. So I've always found, so that's Diana Deutsch's work, and other folks are really working on that too. So I've always found that to be exciting, but that would suggest that there's a certain amount of repetition that is almost required for something to be heard as music.
Great. And just a tiny follow-up. I was wondering if you also looked at things like openness to experience as a kind of like as maybe a variable in terms of, what I'm thinking is that, people that might be more open to new experiences will be more interested in less predictable, perhaps, kind of like, sort of stimuli. So yeah, I was just wondering if...
Yeah, we have looked at, that's a great question. We have looked at openness to experience. It does seem to correlate with people's ratings in general. We haven't looked specifically at when the inflection point is for comparing people with higher openness and people with lower openness, and that would be a really great thing to try. So thank you.
Great, thanks.
I was kind of going to add one thing to this, that it's possible that the behavior of, that both artists and broadcaster or purveyors of music like Spotify are optimizing for the same things, even though they don't understand the mechanism. So, the way repetition happens in playlists and in, pushing artists to be successful is to kind of maximize the reward for the most people. And maybe there is kind of a parallel evidence in just, the way, but also historically, that before there were Napsters and Spotify, when kind of radio play, producers pushed radio play to the point where they made something very familiar and therefore very popular. And I think I'm wondering if the data there kind of echoes a kind of very similar thing.
Yeah, I mean, I think it would be great, such a rich source of data to think about how Spotify listens, right? Now that you have a lot more, as you say, we have a lot more agency in how many repetitions of each piece of music we hear each day, compared to when it was like the options were turn on certain radio to this channel or to that channel. yeah, it would be great to see how, you know, this complexity and this preference mapping scales with the reward system. So yeah, I mean, I don't know of any of a lot of data that's directly addressing that, but I do know that there's some data looking at changes in preference over the course of a day, for example, right? So in the morning, you tend to prefer more complex pieces of music. In the night, you tend to prefer more calm music, unless if you stay up past very late and then you prefer all the very sensory motor dance music. So that kind of, you know, those kinds of big data analyses are super interesting. And then relating those to like musical features that you predict from exposure to music in your culture would be really great to play with as well.
So we are almost out of time, unless there is one final question that anyone wants to
I see that
answer.
Hannah Gibbs has sent a very nice note, so it's good to meet you. Yeah, Hubert Ho is actually he's a good friend, and we went to grad school together, and now he's a professor in the same department, of course. And his music was some of the music that we use for the unfamiliar pieces of music in the functional MRI.
Is it Dinosaur Annex that I think he?
Yeah, he directs Dinosaur Annex, but some of the music that we use was actually composed by him. I think even before he took over Dinosaur Annex.
Yeah, I loved my time at Northeastern. I took My Music in the Brain module, which got me into music psychology, and here I am studying a PhD now in York in music psych. So
great. We have a combined major in psychology and music. I would say we have quite a few faculty are interested in music and psychology, music and neuroscience. Yeah,
it seems to have grown a lot since I was there. It was start of 2018 that I was there.
That's when I started in 2018.
Yeah. Oh, I think we probably just about missed each other, which is a shame. But yeah, it's really nice to meet you now. And thank you.
Thank you.
So thank you very much for joining us from Boston. And this is the last seminar of the first series. And I'll be beavering away and hoping to resume another set in September or October. So thank you everyone for joining, and I will see some of you in September, hopefully.
Thank you.